Not long ago, the site where I'm now standing was simply a greenfield site on a modern industrial estate close to the M5 here in Gloucestershire. Until, that is, the contractors moved in, clearing an area as big as 3 football pitches, excavating thousands of tons of earth to a depth of over 12 metres, to lay the foundations of what was to become an investment of over £1 million. A crucial investment for Kent, and a turning point for the oil, water, power and processing industries. Because here, an entire factory and calibration rig have been custom built from scratch with the express purpose of manufacturing and testing flow meters to the highest possible standards. In fact, this is one of the world's largest calibration and test facilities for flow meters and control valves. And what makes it particularly important is its ability to run continuous tests. Continuous tests on meters and valves up to 2 meters in diameter. So large, in fact, you could drive a car through them. And for testing on that scale, you certainly need a lot of water. Beneath this building is a swimming pool-sized reservoir containing 1,000 cubic meters of water. Not a conventional reservoir, but with a shape specifically designed to eliminate aeration, which could create unwanted inaccuracies. Because, believe it or not, the immensely powerful pumps which drive this plant can recirculate the entire 1,000 cubic meters in only 6 minutes, which means that these pipes can carry over 10,000 cubic meters per hour. That's almost 3 tons of water every second. Follow me. This is where most of the action takes place. Most visitors find it somewhat confusing at first, which is why we've produced this program. But the most important thing to remember is that all of this has been done to ensure accuracy and reliability. Using exactly the same technology that's employed in the multi-billion-dollar business of fiscal oil measurement. As you might expect, this maze of pipework hides a thoughtfully considered logic, a logic which ensures total accuracy of measurement, right back to the traceable standards. The basic principle is that the meter under test is in the same flow loop as up to 4 highly accurate reference standard meters. The output from these reference meters are read by the computer and compared against the readings from the meter under test. There's the meter being tested. The reference standard meters are located outside. These valves allow water to flow down any of these lines. And depending upon the size of the meter under test, you can connect it into a line directly or via a system of concentric cone pieces. In fact, you can fit, test and remove meters on different lines at the same time, which is a great aid both in efficiency and flexibility. The plant can accommodate any meter size, from 300 millimeters right up to 2 meters. Obviously, the same holds true for control valves. And speaking of control valves, it's worth noting here that the valves controlling this plant are all high-integrity block and bleed types to ensure 100% accuracy of flow diversion around the rig and prover system. Below me are 4 massive pumps, and that's the noise you can hear. Each of them can be operated either independently or in parallel. Let's go and have a look. This pump is used in every test. It's a variable speed pump, which could be used independently on a small meter or with up to 3 other pumps for a large meter. Flow rate control for the entire plant is exercised via those throttle valves. The same principle applies to the reference standard meters, which are outside. Once again, up to 4 of these extremely accurate turbine meters can be deployed in a test. That's all very well, you might say, but how do we know that the reference standard turbine meters are accurate? A fine point, and one that's not lost on Kent's designers, which is why the system incorporates a high-precision mechanical displacement meter prover. In testing the accuracy of the reference meters, a liquid-filled plastic sphere is passed through a prover loop, activating detectors which tell the computer when the sphere has swept out a precisely known volume of water, which has also been passed through the reference flow meter. The prover loop test is conducted in both directions, and the computer stores the relevant data for comparison against the meters or valves under test. To ensure the greatest accuracy, up to 5 consecutive calibration runs are performed within extremely close tolerances to establish the meter coefficient at regular intervals. The prover loop is calibrated by an approved independent authority. Now we've discussed the basic principles, let's take a look at a typical meter under test. The first step is to fill the system and to run the plant up to its desired flow condition, and to maintain that flow rate until the air is purged from the system. Tests can be conducted either short-term or continuously. A typical production calibration for a Kent Veriflux flow meter, for example, would consist of 5 runs, and the computer prints out the results on this official certificate. This first display shows a typical Veriflux calibration run with customer information, the date and so on. It also gives information on, for example, flow rates through the transfer standard meters and the meter under test, and real-time data of flow characteristics. This display is a calibration graph of instantaneous readings. These are tabulated values. And here is the calibration characteristic, which is printed out here on the customer's calibration certificate. The test system is entirely automatic, and it's impossible to enter test data via the keyboard, so the integrity of the test is guaranteed. An important feature of the plant is that the computer automatically applies temperature compensation during the test. The large calibration rig is only one part of the overall Kent flow calibration capability. A variety of other test rigs can handle meters as small as 3 millimeters in diameter, with flow rates as low as 12 litres per hour, and further enhancements are well underway, which will maintain the plant's leadership performance well into the next decade. It all underpins the importance the Brown Boveri Kent Group place on their customers in the oil, water, power and process industries. Many customers outside the group make extensive use of this facility, which is the only UK or European facility able to operate continuous flow testing at rates of up to 10,000 cubic metres per hour. And it's through investments in performance testing such as this that Kent Industrial Measurements, and indeed the entire Brown Boveri organisation, of which it's but one part, are able to keep abreast of the increasingly stringent demands placed on their flow metering and control valve products. To give customers that accuracy, reliability and cost-effective performance so important in today's economic climate. All of which means, in short, that you can place complete confidence in the accuracy, reliability and integrity of Kent flow metering technology.